Right now, at this exact moment, you exist. You're breathing, you're thinking. And I know that sounds obvious. But stay with me for a second, because the fact that you're here at all is so unlikely that it almost didn't happen. We tend to think of Earth as this stable, reliable planet that was always going to have life, like it was written somewhere, like it was inevitable, but it wasn't. The reason anything complex ever evolved here, animals, forests, consciousness, you, came down to one single moment, one collision, 4.5 billion years ago. And the evidence of that collision? It's sitting right there in the sky every night. The moon. Most people don't think much about the moon. It's just there. It looks nice, controls the tides. You've seen it 1,000 times. But here's what most people don't realize. The moon is not a decoration. It's not a coincidence. The moon is the single most important reason life on this planet got complicated enough to produce a species that can ask questions about its own existence. Take the moon away, and Earth is a barren rock. No forests, no oceans full of creatures, no humans, nothing. And here's the part that genuinely unsettles me. We're losing it. Right now, as you watch this, the moon is slowly drifting away from us, and when it's gone far enough, everything changes again. So let's talk about how the moon got here, why it literally kept you alive, and what happens when it leaves. 4.5 billion years ago, the solar system looked nothing like it does today. It was chaos, absolute chaos. Young planets forming, colliding, absorbing debris. The early Earth existed, but barely. No oceans yet, no breathable air. Just a hot, molten ball of rock and metal still trying to figure out what it was going to be. And sharing Earth's orbital path around the sun was another planet. We call it Theia, named after a titan in Greek mythology, the mother of the moon. And Theia was roughly the size of Mars. This wasn't a rock. This was an actual planet, thousands of kilometers across, with its own iron core, its own gravity, its own history. For millions of years, Theia and Proto-Earth orbited the sun in similar paths, held in this uneasy gravitational balance. But the early solar system was unstable. Gravitational nudges from Jupiter, from Saturn, slowly pushed Theia out of that balance. And once it started drifting into Earth's path, the outcome was inevitable. The collision happened around 4.5 billion years ago, and I want you to picture this correctly, because it wasn't two rocks smashing like billiard balls. It was more like two molten planets merging. Theia hit Earth at an angle, a glancing blow, at about 40,000 kilometers per hour. Both mantles, the outer rocky layers of both worlds, were instantly vaporized, liquefied, blasted outward into space. The iron cores, those merged, they sank together and became Earth's new, larger core. And all that vaporized rock, billions of tons of it, was thrown into orbit around Earth. It formed a ring, a massive ring of debris, dust, and molten droplets circling our planet. And then, in a time frame that scientists estimate somewhere between a few hours and a few thousand years, that ring coalesced. Gravity pulled it together, and the moon formed. Now here's something that always gets me. The reason we know this actually happened, the reason it's not just a theory, is because of the rocks the Apollo astronauts brought back from the moon. When scientists analyzed them, they found that the moon's chemical composition almost perfectly matches Earth's mantle. The oxygen isotopes are nearly identical. The moon and Earth have the same chemical fingerprint. Because the moon isn't some captured asteroid, the moon is made of Earth. Pieces of our planet, thrown into space by the most violent event in this solar system's early history, reassembled into something new. Now, why does any of that matter to you personally? Because what happened next is where it gets genuinely strange. The moon didn't just form and sit there. It actively shaped the conditions that allowed life to become complex, and it did this in ways that most people have never heard of. First, axial tilt. Earth rotates on a tilted axis, about 23.5 degrees right now. And that tilt is why we have seasons, and seasons matter enormously for complex life. They create evolutionary pressure, they drive migrations, they cycle nutrients across the planet in ways that feed biodiversity. But without the moon, that tilt wouldn't stay at 23.5 degrees. The gravitational pull of Jupiter and Saturn would slowly push and pull Earth's axis in all directions. Scientists have actually modeled this. Without the moon, Earth's axial tilt could wander chaotically anywhere between nearly 0 and up to 85 degrees, swinging back and forth over tens of millions of years. Think about what that means. At 85 degrees of tilt, the poles are pointing almost directly at the sun. One hemisphere gets months of continuous scorching heat, then months of absolute darkness and cold. The climate swings would be so extreme, so fast on geological timescales, that complex life almost certainly couldn't maintain a foothold. The moon locks our tilt in place. It acts like a gyroscope for the entire planet. Second, it slowed Earth's rotation. When the moon first formed, Earth was spinning incredibly fast. A day was around 6 hours long. The moon's tidal forces, pulling on Earth's oceans and crust across billions of years, gradually braked that spin. Today, a day is 24 hours. A longer day means more stable temperature cycles, less violent atmospheric circulation, more hospitable conditions across the surface. Third, the tides themselves drove life out of the ocean. The moon's gravity creates tides, and tides over hundreds of millions of years created intertidal zones, those coastal bands that are sometimes underwater, sometimes exposed to air. The organisms that evolved to survive in both environments had to become more adaptable, more robust. Those are the ancestors of everything that eventually made it onto land. The tides didn't just move water, they trained life. So when you put all of this together, the tilt stabilization, the rotation braking, the tidal pressure on evolution, what you get is this. The moon didn't just form, it engineered the conditions for complex life to exist here. Change any one of these three things, and Earth is probably a very different story. Maybe microbial, maybe barren, but not this. Here's where it gets uncomfortable. The moon is moving away from us, not in some distant future scenario. Right now, at 3.8 centimeters per year. We know this with extreme precision because Apollo astronauts left laser reflectors on the lunar surface, mirrors essentially, and we bounce lasers off them from Earth and measure the return time down to the nanosecond. The moon is retreating, every year, slightly farther away. Now, 3.8 centimeters a year sounds like nothing, and over a human lifetime, it is nothing. But on geological timescales, in roughly 600 million years, the moon will be far enough away that its stabilizing influence begins to weaken. Earth's axial tilt will start to drift. Climate swings will grow. The window that allowed complex life, the window we are currently living inside, will start to close. The sun will probably expand into a red giant long before the moon's retreat becomes truly catastrophic. So it's not the moon leaving that ends us, but it is a reminder that none of this is permanent. Nothing in the universe is. The moon is leaving, quietly, slowly, the way everything changes, too gradually to notice in a lifetime, but absolutely certain across deep time. The next time you look up and see the moon, I want you to really see it for what it is. That is not a rock that happened to be there. That is the debris of the most violent collision this planet ever survived. It is the reason Earth has stable seasons. The reason your evolutionary ancestors had enough consistency to develop complexity, the reason something eventually crawled out of the ocean, the reason you exist. You are here because 4.5 billion years ago, two planets hit each other at